Learning target 2.10. I can define a cation and anion and represent them using symbols. Okay, so let's start with what a cation is, or actually what an ion is. An ion is any atom with a different number of protons than electrons. Okay. A cation is going to be any atom that lost an electron. Right? If it loses an electron, it's going to be more positive. That's how I remember that a cation is positively charged. Okay, so let's backtrack a second just to be clear. Okay, when you have an atom, it's normally neutral, so it normally has the same number of protons as electrons, right? If it has 3 protons, it has 3 electrons. They cancel each other out just like that. Cation is going to be when you have more protons than electrons, right? You start off with something neutral, but oh, it lost an electron. So now these cancel out, but it's positively charged. That's a cation. An anion is any atom that gained an electron. So it's going to be negatively charged. Negatively charged. Sorry. Okay, here's why. So let's say I have my 3 protons, 3 electrons. I just gained another electron. Well, these cancel out. I'm left with a negative charge. How am I going to remember that? The T in cation look like a plus sign. The N in anion will stand for negative. How nice. Okay, so given this, right, don't forget, cations lose electrons. Anions are the ones that gained an electron. Okay. Now, how do you show a cation? Well, let's take a look at magnesium, for example. So magnesium, if it loses 2 electrons, how do we show that? What we do is we use a superscript, super meaning above, and we say 2 plus. The 2 is the number of electrons, and the plus is the charge. So magnesium, if it lost 2 electrons, right, then it's going to be, as my notes say, positively charged, right, and the 2 tells me the number of electrons. Let's try one with an anion. Let's say we have oxygen. Oxygen gained 2 electrons. Then it's going to be O, 2 electrons, right? That's the number of electrons. And if they're gained, it's going to be negative. So, actually, it gets even better because now Mg and O can form a compound, and everyone's happy. Okay. Let's go ahead and try an example problem. You can sort of jot this down as best as you can, but I know we're not all perfect at drawing 3D symbols, which is why I printed mine out. Here's a question. This image represents part of a crystal of a salt composed of lithium and fluorine. Okay, so first of all, just as an FYI, if you did not know, salt is anything that is a plus and a minus. Okay, so table salt we know is NaCl, that's Na plus, and Cl minus. But you can have a bunch of salts that, as long as there's a plus charge and a minus charge, you're good to go. Okay, so given this piece of information, this was key. Particles of lithium and fluorine in this salt crystal are most likely, well, if we know that it's a salt, we know that there's a positive and negative charge, a cation, and an anion, negative, positive. then the particles of lithium and fluorine are most likely neutrally charged? Nope, they've got a charge. They're not neutral. Negatively charged? Well, it would be Li plus and F minus, so they're not they're not both negative. Positively charged, they're not both positive. They're oppositely charged. One is a plus, one is a minus. Here's my answer.